Section 2.7. We record the average rate of change of y with respect to x is the first derivative of the function f of x. In physics, if we consider s equal to f of t is the position function of a particle that is moving in a straight line, then to find the velocity, we take the first derivative of the position function. And to find the acceleration, we take the second derivative of the position function or the first derivative of the velocity. The acceleration is the rate of change of the velocity with respect to the time. Example number 1. The position of a particle is given by the equation s equal f of t equal t to the third power minus 6t squared plus 9t. And t is the seconds, and s is meters. We want to find the velocity at time t, so we just take the first derivative of the function f of t. Then we will get 3t squared minus 12t plus 9. What is the velocity after 2 seconds? So after 2 seconds means that t equal to 2. And then we plug in the velocity function. That means we evaluate the function v at t equal to 2. And we will get the answer is negative 3 meters per second. And the velocity after 4 seconds, that means we will plug in 4 into the function v. And we will get the answer is 9 meters per second. So we plug into this function. When is the particle at rest? At rest means v of t equal to 0. That means that 3t squared minus 12t plus 9 equal to 0. We factor out the 3, so we get t squared minus 4t plus 3 equal to 0. We continue to factor, so we get t equal to 1 and t equal to 3. So the particle at rest, that means no moving, so velocity is 0 when t equal to 1 and t equal to 3. When is the particle moving forward, that is positive direction. So v of t positive. That means we have t minus 1, 3t minus 1, t minus 3 greater than 0. We divide both sides by 3, so we get this. And if you remember how to solve the inequality in algebra, we put the number 1 and 3 on the number line, and then we test in the point. So when we test in the point, we will get positive here, negative here, and positive here. So for the v of t positive, that means t have to be less than 1 and t have to be greater than 3. Draw a diagram to represent the motion of the particle. So let's assume that we have, this is the distance starting from 0 for s. And when we travel from 0 to 1 until 1 second. So this time means t equal to 0 and s equal to 0. So that is the beginning. So when it's moved positive direction, when t is hit 1, right? So right here we have t equal to 1. So when you plug in t equal to 1 into the function f of t, which is s, is give the answer is 4. So S is 4, okay? And then it will travel forward. And then and hit 3. So right here is t equal to 3. And when we plug in t equal to 3, then f of 3, which is s, you will get the answer 0. So we have right here 0. And starting from 3 is go positive direction. You notice that this is just one dimension, and the particle just move like this, back and forth, back and forth. But we draw separate so that you can easy to understand. But understand this is together, okay? This is one dimension only. Find the total distance traveled by the particle during the first 5 seconds. If we just right away look at the time t equal to 0 and the time t equal to 5 to see the difference, we will have a problem, especially if we just look at, let's assume that we just look at 3 and time from 0 to 3. The distance from 0 is 0. The distance when t equal to 3 is also 0. Then it means that the particle does not move at all. But it's not true, right? It's just because it's go opposite direction. That's why it cancel out. So in this situation, we need to break down into pieces. So we're gonna do from 0 to 1, from 1 to 3, and from 3 to 5. So we take f of 1 minus f of 0, f of 3 minus f of 1. And because we're doing distance, so we want to make sure our number to be positive. So what all you need to do is just plug in those numbers into the function, but I already have that before. So we have 0, f of 0 is 0, f of 3 is 0, f of 1 is 4, f of 5, when you put 5 into the function, you get 20, and f of 3 is 0. So you get 4, 4, and 20. That means you add 4, 4, and 20. So the total distance is 28 meters. Find the acceleration at time t and after 4 seconds. The acceleration is the second derivative of the position function, which is the first derivative of the velocity. So we will get 6t minus 12. We take the first derivative of the velocity, okay? And we evaluate the acceleration at 4. And we get the answer is 6 times 4 minus 12. And the answer is 12 meters per second square. Graph the position, the velocity, and the acceleration function for t between 0 and 5. What all you need to do is just go to the technology and enter the function f, the function v, and the function a, right? So the function a is 6t minus 12. The function v is 3t squared minus 12t plus 9. And the function f of t is t cubed minus 6t squared plus 9t. So if you pay attention that f of t is the dot exponent, so something like this. The velocity is parabola and the a is the line. So we have the graph below. And then when is the particle speeding up? When is it slowing down? So the line A is an acceleration function. The parabola, which is the v, is in the blue color, and in the pink color is the s. Okay, so the particle speeding up, speeding up when we have v of t and 8 of t are the same side. Same side mean they both positive and they both negative. Okay, so you look in the graph and you can see that from here, speeding up and speeding up. So you look at this. So from this distance, and you look at this. So both graph, the green color and the blue graph, they are both in below the t. Below, that means they both negative. So they are in the same side. And right here, starting from this point and this, they both positive. So they are both negative and they both positive. And we have the labeling is from 1, this is 1, 2, 3, 4, and here's a 5, right? So in the interval from 0, sorry, from 1 to 2, and from 3 positive, more than 3. And when it's slowing down, when v of t and 8 of t are different side. Okay, so we look at the graph and we can see that slowing down. So from less than 1, you see that the a is negative but the v is positive. Okay, less than 1. And also between 2 and 3, the v is negative and the a is positive. So the a is up. So t between 0 and 1, and t between 2 and 3. So it's okay that they both equal to 0. For the time t, right? We're starting from 0 for both of them.